All right, y'all. So this is the probability part 3 notes. This is what we went over in Unit 5. So this is what we did right before Christmas break, and then right before we started all of the inference testing. So just some, want to go back over some keywords and some things that are really important before we dive into the example. So a z-score calculates the total number of standard deviations that the data is located from the mean. Now remember, we calculate the z-score by doing the x minus the mean divided by the standard deviation. Being able to use a normal model and convert to a z-score helps us understand the probability of obtaining that data point, which can be applied when we run a test, as we know. So a normal curve has a symmetric distribution about a mean of 0 and a standard deviation of 1, where the area under the curve from negative infinity to the z-score represents the probability of that point or less occurs. The data follows a normal distribution, and we can convert it to that using our z-score calculation. Okay. Now this next little piece here, let me erase that. Is really important. So roughly 68% of the data will be within 1 standard deviations, 95% within 2 standard deviations, and 97.7 within 3 standard deviations. Since the distribution is symmetric, the cumulative area under the normal curve sums to 1. Okay? A sampling distribution occurs when repeated samples of size n are randomly selected from the population and a collection of the sample means is plotted. If the samples are taken from an approximately normal population, then all sampling distributions will follow exactly a normal distribution. If samples are taken from a non-normal population, then sampling distributions with a sampling size greater than 30 means will approach normal. So remember, that is that really important central limit theorem that we use later in our inference testing. And then we know that if we're using a sampling distribution, that we're going to use this new formula for the mean. These are included on the formula chart, so just make sure that you're leveraging that resource as you're working through the test. All right, so let's go over the empirical rule. So the empirical rule is this idea that we know what the normal curve looks like, and that means we can leverage it to make some conclusions. So we just kind of went over this, but I want to go back over it. If we're looking here, 1 standard deviation away on the left and 1 standard deviation on the right, that is going to be 68% of our data. Okay, and then if we go out even further, say to 2 standard deviations away is 95%. Now you can figure all of this out from your z-score and all of those in the z-table. However, it's important to have these kind of memorized because it helps us sometimes. Now, if we have 95% of data in the middle, that means the data left on the outsides is 2.5% and 2.5%. And this will be important when we're doing confidence intervals later in the course, as you well know. So let's look at this model problem. So the mean height of a seat of a standard high school student's chair attached to a desk is 18 inches. So it tells me up front that the mu is 18 inches. Okay. And with a standard deviation, so I have a standard deviation here of 0.6 inches. The height of all high school student chairs attached to the desk can be reasonably approximated as normal. So we want to know what proportion of high school students' chairs attached to a desk have a height that is greater than 19 inches. Okay, so if we're looking, this is the number we're going to use to z-score. So when we do our z-score here, we're going to have z equals 19 minus our mean, which is 18, divided by 0.6, which is 1.67. So when I get a z-score, what I'm going to do is I'm going to go to my normal curve, something like that. And I want to put my mean in here. So this is my mean of 18. And then each little tick mark is a standard deviation. So I'm not a full 2, so it looks something like this. And then I shade here. Okay. And this is 19. Now to find this probability, I'm going to go to my table and I am going to read it so that I have a z-score of 1.67. So here is 1.6. And here's the 0.7. So I'm going to go to where that is. Now, if you'll notice, I got 0.9525, but look at the shading here. So if this is 0.9525, then this is going to be 1 minus 0.9525, which is going to give me a probability in my example of 0.047, not 8. Okay. So let's look at the next part. So that's how I find this probability of getting a chair that is greater than 19. Now, a random sample of 5 chairs is to be chosen. What is the probability that exactly 2 of the chairs, so this is kind of, I should use my, have a height of greater than 19 inches. So if I'm going to use this, this is a good example of when to use a binomial, right? My number of trials is fixed. So I have a probability, my n is 5. My probability of success is fixed at 0.0478. And then I would like x to be equal to 2. So when I do this, I am going to do 5, choose 2. The probability of my success, and I want to get 2 of those, and then my probability of getting not a chair of that height, and I want 3 of those. And when I type that out, I am going to get 0.197. Okay. All right, so this last little part says, what is the probability that the sample mean of 5 chairs is greater than 19 inches? All right, so this goes back into that using this formula, right? I took a sample of my distribution. So here I would like the mean of all the sample that I took. So I want my x bar to be greater than or equal to 19. Okay, so my mean x bar is going to be equal to 18, and my standard deviation x bar is going to be equal to my original standard deviation divided by the square root of the number in my sample, which is going to be 0.27. So now I'm going to z-score with these numbers right here. Okay, so my z-score in this one is going to be 19 minus 18 divided by my new standard deviation, which is 0.27, and that is equal to 3.70. So if I'm thinking about my normal curve here, this is going to be so here's my mean of 18, and I am 1, 2, 3. It's going to be a very, very, very tiny number. So let's go look at our table, our z table, and see what's going on. So our z-score was 3.7. Y'all, this isn't even on the table. So we're going to estimate it as p equals 0.0001. So that's really small, so we're going to say very unlikely. All right, that's a wrap. Please finish the Check My Understanding problems to be ready for a class tomorrow.